So, in today's lecture, we're going to be looking at semiconductors. We'll see a brief introduction to what is semiconductor. We'll look at the valence band and conduction band, and then we're going to be looking at a couple of simple derivations. So, this is just going to be an introductory class, sort of. So, to start with, a semiconductor is a material whose electrical conductivity lies between that of conductors and insulators. In other words, it cannot conduct electricity as well as a conductor or a metal does, but it is better than insulators or non-metal. So its conductivity lies in the middle between conductors and insulators on the spectrum. And why is this so? Because of thermally generated electron-hole pairs. So what does this mean? We'll take the example of silicon, but the same principle applies to any semiconductor you take. So if you take a silicon atom, the atomic number of silicon is 14 and the arrangement of electrons will be 2 electrons in the innermost orbit followed by 8 in the middle orbit and then 4 in the outermost. So if you remember from your high school chemistry, an orbit needs to have 8 electrons in order to be fulfilled. So the outermost orbit, which has only 4 electrons, is in need of 4 more electrons. So how does a silicon atom usually fulfill this need? Is by making covalent bonds with 4 other silicon atoms. So this represents the electrons in the outermost orbit of a silicon atom. So you can see it enters a covalent bond, or 2 atoms share their outermost electrons. That is how generally the need for electrons is fulfilled. Now what happens when you supply energy? That is what we mean by thermally generated. It can be thermally, electrically or optically, as in heat energy, electrical energy, or by shining light of sufficient frequency. When you supply energy, these electrons get excited and they move out of their orbit to higher orbits. So when that happens, a free electron is created first of all, meaning an electron which is roaming around in a higher energy orbit, and secondly a vacancy or a hole is created in one of the lower energy orbits. So every time energy is supplied leading to displacement of an electron, a free electron and a hole are simultaneously created. This electron-hole pair is capable of conducting electricity. That is why at higher temperatures or when a larger quantity of electricity or light are supplied, the conductivity of semiconductors increases because more and more electron-hole pairs are going to be generated.